Okay.
Sure, no problem.
So.
I already did it, but I had one wrong, so.
Oh, okay.
We'll figure it out.
Okay. So we're live. Let's go ahead and get started. If everybody could pull up the quiz.
Okay, cool. All right. So we will need SPSS in a couple questions, just so you all know. The true linear regression equation is y equals b0 plus b1x, where b0 and b1 are unknown. What are the null and alternative hypothesis? Null is equal, right? And then alternative is the one that's not equal.
Mm-hmm. Should be C then.
Yeah.
B. Yeah. It works. Okay. All right. A residual is what? Is the difference between B0 and B1, depends on the dependent variable, is the difference between the observed value y and the value predicted of the regression line, or is what is left over after doing simple linear regression. It sounds like B or C, but let me look.
I'm thinking C too, but I can't remember.
Yeah, I can't remember. I'm going to look it up.
Yeah. Well, for the residuals plot,
I have to open my book. I forgot about
the residuals plot, obviously, it's.
I'm still opening my quiz, sorry.
This all good.
Hey, Jacob. Pretty good. Glad you could join us.
Okay, so residuals. The residual for an observation is defined as the difference between the observed value of y and the value that would have been predicted. So it's C, right?
Yeah.
Yeah. I think it's C.
Yeah.
Number 4. According to. All right, 5. Is everyone ready?
Yeah.
Sorry,
Yeah.
Once you organize,
Yeah, just keep going because I just opened the new one and I need to go
Okay.
back and find the old one.
Okay.
Okay.
A plot of residuals supports using linear regression when the result looks normally distributed. The residuals are all positive. You see a megaphone shaped in the residuals. So it's when there's no pattern, right?
I think
Wait.
so.
C? Because it's just not supposed to have a pattern.
Which one are you on now?
5?
Oh, okay. I got A. The residual looks normally distributed.
It shouldn't be normally distributed. I thought it was a scattered. It was all everywhere. The residual plot.
Yeah, well, that's what it shows. When it's all scattered, that's because it's the right. It's normal.
Yeah, that means that it's normal.
Yeah.
But it says the plot of residual supports using linear regression when the results.
So it's saying linear, so it has to be normal for it to show a line. So.
Oh, I
think,
get it.
yeah.
So it's talking about the information is normally distributed if the plot of residual supports it. Right?
Yeah.
Yeah.
Okay. So it's A?
Yeah, I got it right. So I think.
Yeah, so it's A.
Yeah.
Okay.
Nice.
Okay, so we'll need SPSS for this one. For the next 8 problems, use the data found in math self-efficiency. Use the confidence variables as an explanatory variable. And the score variable as a response variable. So response is Y, explanatory is X, correct?
Yes. Mm-hmm.
Right?
Response is
Okay.
Y. Yeah.
So confidence is going to be X then.
So we're looking at the confidence
Going to
interval
SPSS.
for the slope, B1. Yeah. Yes. Do you need us to go over the first answers, Jacob?
Sorry, might take me a little bit.
Yeah, mine's taking
Oh, you're
forever
good.
too.
So what did you get for number 3?
We will be computing the residuals for this one.
Oh, okay. Okay. For at the end as well.
And how do you compute the residual again? I like forgot.
We're
Go
up
to
to
the
question 12.
descriptives, linear, and then it's in the options.
The math
Wait,
itself,
or do you
you
save
see,
it?
Save. Yeah,
and then
save.
You save it.
have to
You
figure
save
out
it. That's what it
up
is.
until 12 off of that.
So under
6 and
Explore?
12 or whatever
So
it
you,
is.
so you by vibrate it.
Analyze. Mhm. No,
See,
no, you go to
by-
linear. You go to linear.
Okay, I was thinking that, but I wasn't like. So you go to regression linear,
Oh, okay. I was
I
like,
would say
which
fail
one do I
to-
forgot?
or
regression linear,
that
and
fails
then you can
reject,
do
right?
confidence as X
Because
or
it's so high.
independent, right?
Mm-hmm.
And then score
Sorry,
as
just say-
dependent.
Okay. And then you save,
Then you go
right?
to statistics, and you go to no, you don't go to
There you go as well.
statistics. You save it,
And,
and
click
that's
on
where you do unstandardized residuals. Continue. Okay, should pop up, and then you plot it.
So be a
So now you can go to graphs, legacy dialogues, scatter dot, and then you push define, and you use the confidence rating as X still, and then you use unstandardized residuals as the Y. And then you push OK.
so
Then
question 13.
We come up with a crazy plot thing. So I think it supports
We
it.
reject the null. Options 2 and 4. For the option
Compute the
4,
residuals for the
find
data
that
using
it's not
software.
0,
What statement best describes the residuals?
or find that it is 0.
So the residuals form a linear pattern, the residuals are all negative, or the residuals are between negative 40 and 25.
Yes, that one.
That one,
The
yeah.
negative 40?
Oh, that's right.
Mm-hmm.
They are not, though.
One is 38.
Yeah. Yeah, one's 38.
But they say about.
Well,
They're
actually,
Okay,
not a
because
question,
the other ones
saying
aren't right, so it has to be that one.
if we reject the null.
It
Yeah.
has to be A because the other ones aren't even right,
So
so.
yeah, you're right.
Okay,
What if
Yeah.
if they would have said between negative 40 and 40 or something?
it's about right. It's
Yeah.
about right. It's the most true of this answer. All right, based on the QQ plot for the residuals, what can you say? Now we need to go QQ it by going to analyze, compare, or descriptive statistics, QQ.
Oh, good. I need to rearrange the
And then you plug in your variable of unstandardized residuals,
oh, that's the one I got wrong.
and we get a normal looking P. Well,
I think that's
It's normal
fairly
enough.
normal. Yeah.
it's pretty normal. It's
It
normal.
looks normal. It's like right along the line. So
Residuals look fairly normal. So it's B.
yeah.
Are we writing these down?
Yeah, I am.
Yeah.
Possibly. I think we're good. Anyway. All right. Use software to create a scatter plot of the data. Given the scatter plot, residual plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data?
13, we found
Ooh.
it was,
Cool. There is linear relationship
The
between
bottom
X and
one.
Y.
yeah.
Are they being tricky? Given the
Yeah.
scatter plot, residual plot, and the QQ plot, it means that the residuals are normally distributed, and it means that the X values are measured without error.
What we got was the dependent variable.
And one
because
more.
The body only depends on
Where's
the
that chart?
headline. So we actually put a headline.
The chart says
They're measuring
linear
the
relationship
to predict
is
what
the scatter plot
depends on the
and the residual plot.
to predict what
Normal error
the body will be.
term would be QQ plot. Constant variance would be residual plot, and X's
So is body.
are known constants we can't really figure out, and observations are independent we can't really figure out. So knowing that, linear relationship,
Oh, okay.
residuals normally distributed, the X values are all measured without error. So A, C, D,
Okay.
That's what I got.
does that sound right?
Yeah.
I got A, B, and C.
Did you get it right?
Yeah. I got 1 point.
Really?
Mhm.
Yeah, I know, right?
The residuals are normally distributed. The variance of the error term is constant for all the values of x, and there's a linear relationship.
Oh wait, they might be in
The
different
other two I
orders.
left out.
We
Oh.
might be in different orders. So there's a linear relationship between x and y.
Uh-huh.
The residuals are normally distributed, and the x values are measured without error.
That one I didn't mark, and it marked it right. Do you have the variance of the error term is constant for all the values of x? Do you
Yeah.
have that choice?
Yeah.
So it's B for me.
So they are in the same order then. Okay. So variance.
What did you get for it?
So variance of the
They
error
are?
term. Let me look at the chart one more time. Oh yeah, it is constant variance. Oops.
Yeah, because it shows on the key
Yeah.
plot.
Yeah.
It's like a
That
line.
was weird of me. So it is constant variance. It's not the x values are measured without error. That's stupid. Wait. Yeah. So it is A, B, and C. There's linear relationship. The variance of the error term is constant for all values of x, and the residuals are normally distributed. That makes sense. Okay. What is B1 of the estimate for the slope? I guess we gotta go chart this thing.
Don't we already have it
So
from
wait, I'm
earlier?
lost here.
Above
I didn't
our
actually
graphs
graph
and
it. Did it have the?
We're finding
Oh yeah, it
the
does have the
slope
B
B1,
variables, doesn't it?
right?
It's under B, right?
stuff. I think so.
Under standardized coefficients, so it's the 18.690 and the 12.695.
Yeah. So
Okay.
B1 is the 12.6.
Yeah, the confidence rating mean is 12.695.
Mine has a high of 1.135.
And then B1 now construct 95% confidence interval, which we can also do by adding on a couple extra stuff in our analyze,
I erased it all.
Yeah.
regression, linear. I should have just added that on in the first place.
But you go to statistics, yeah.
Yeah, and then you go to confidence interval, and then continue,
Yeah.
and then cool beans, and we get
Hold on a second.
we use the
We're doing
top
body
one or
length
the bottom
first,
one.
right?
What are we looking for again?
And like,
The lower.
Let me see.
The lower
I feel
one.
like we used the
Lower,
bottom one, but
10 is lower.
So it's the 10.674.
Yeah.
10.674.
okay.
I just remember that being confusing to figure out which one to use.
yeah.
Upper
I
bound.
feel like I've just decided that we
Yeah,
always use the bottom
we're
one, but it's
using
hard to tell.
B1, which is the slope, and
I
it's
got
the
0.442.
X, right?
I think so. Did you get this? I don't know. 14.715 is the
For
next
upper.
one, right?
Yeah, that's what I got.
14.715. Reads.
Yeah.
All right, 12. Based on the evidence and using level of significance, what decision would you make regarding the hypothesis test for B1? So if this is
I literally just,
oh wait, wasn't it 0?
I just selected the cells, so I just did equal
was 0.
sum, selected the upper, selected
So
the lower,
we-
and divided that by 2.
Wait. We reject the null.
We reject. Yeah.
The p-value is less than alpha. So D. Wait, C.
Yeah.
Our hypothesis test for B1 slope. If you reject the null hypothesis, what does it mean?
Yeah, because when I just select the cells, it gives me 0.442.
It means that-
4.
One second.
If I just select it in the Excel
There
spreadsheet,
is
that way.
sufficient evidence. Wait, rejecting means there's sufficient evidence to conclude the slope of the regression line is 0.
Yeah.
Right?
Is
I
not,
think on
because
that
the
end, it
top,
probably
remember the
will give
top,
us a little bit.
we picked, the null is equal 0 and the other one is not 0.
Yeah, so
we're
it's
rejecting,
Oh, because it's different. Okay, yeah, that makes sense. So it's the last option.
sufficient evidence that the slope of regression is 0 or isn't 0.
it is not, it's not, because
Okay, that's
then
what I was-
we'll be
That's
using
what I was
the
thinking,
null.
but
Yeah.
okay. Because the null is equal to 0 and we just rejected it.
Yeah.
Cool. All right, now we're gonna need estuarian crocodile.
Yeah.
We've been using these crocodile ones a lot.
Yeah.
I know, right? There it is. Yes. Let's do it. All right, so we're doing
Yeah.
score and, head length and body length. Head length is the X, right?
Yeah, so question
I think
14, it's
so.
asking the variable, the dependent variable.
Yeah, help you out here real quick.
So that would be,
1 second.
Yeah.
Head length is the X, so it's independent. Body length is dependent. Okay. And then
Well, that's
say,
go back up through.
oh wait, are we doing
So we're saying-
residuals or we're just doing,
they're
I don't
just asking for margin of error and lower and upper bound, so.
No,
oh,
we haven't
okay, so
yet.
I'm gonna go back.
We can go back through with it for you. I don't have much to do.
Regression, linear,
If you
save.
want, Taylor and Sandy, do you guys have?
No, it's not.
So we're
those
saying
you go
head
through
length
with
is
Jacob
independent,
after we're
right?
done if you want to talk about our
There
group
it is.
project.
Head
Body
length
length
is
is
independent, yes.
Mhm.
Okay.
No.
So I have, what's the first question again? For this data, the variable dependent length is head length. Correct. All right, that was 14. 15.
Wait, the dependent variable is body length.
Yeah.
Okay. The
And
dependent
what?
variable.
Independent is body length.
Wait, it's, oh yeah, it is body length, sorry.
Yeah.
I thought it said independent. Okay,
Oh, no.
now 95% confidence interval, determine your margin of error. Is that just minusing, subtracting these two and dividing by 2?
Yeah.
Okay.
Yeah, that's right.
And we do the bottom one, right?
So upper minus lower,
So it would be the 8.103,
minus
Minus
7.7.
7.218 divided by 2. I got 0.4425.
Yeah, so it's point.
So-
0.443.
Yeah.
Sweet. 16. Input the lower bound. That was.
So did we have an
7.218?
explanatory variable start with 4.34 in response?
Everyone's understanding SPSS, right?
Yeah.
Yeah.
Everyone's getting it?
Yeah.
Making sure. Okay. Upper bound was 8.103. Hey, last question. Based on your lower bound and upper bound from the last two problems, what can you say about B1? So, let me think. I remember this question. Where's my homework?
Okay,
Mhm.
because if you do that, and we're creating a 55% confidence.
So we'll
Is it
have
A?
sufficient evidence. Wait, what? I thought it was C.
Oh, actually, it doesn't want to say.
No, it's actually A, yeah.
Really?
We're
was
95%
right.
confidence.
Oh, okay, that does make sense. Wow, I can't believe. Wait, did you get all these right? I thought you said you got one wrong, Lydia.
Yeah, I got number 5 wrong. No, sorry,
Oh.
number 7. Number
Did we
7.
get the right one then?
I don't know. I put a number 7. I put the residuals are clearly not normal. I don't know why, but I meant to put the residuals are fairly normal.
Oh, okay.
So I think it's B. So I think that's the one.
All right.
But the rest, yeah.
So this one for 18 is A. Brilliant. All right,
Yeah.
we're good to submit?
yep.
Cool. I'm submitting.
So then we're at 100%. Okay, Jacob, now we can.
That was really fast,
correct it
guys.
down.
That was.
18 out of 18, 100%.
Yay. Nice job, guys.
That was really fast. All right, now we have more time to talk about our theme about.
So what do you, what do you
All
need for
right,
number
I'm
3,
going to
Jacob?
create a document really quick.
If you remember all the reading.
Hey, I'm just gonna stop the broadcast.